All right, on this first one, you see it says approximate the temperature. So we're looking at a table that's got our temperatures given from 0 to 12 days. And our temperature is done in degrees Celsius of a water in a pond. And so it says estimate, and it says the average here temperature. And that's, again, the function that we have. And so what we would be doing is using that 1 over b minus a, the integral from 0 to 12 of the function we have, but because we don't actually have w of t to plug into the function, we're going to use an approximation. And so that's where this trapezoidal approximation comes into play, is that I will use that to find our integral value here. And our trapezoidal approximation would look like, so our first base goes from 0 to 3. Sorry, I should say height, with 20 plus 31. Our second height is also 3, and bases of 31 and 28. Next base height of 3, bases of 28 and 24. And our last one has a height of 3 also, which means this would have been eligible to do that little shortcut, but I can write them all out separately too. And so we've approximated there, and then I would take this answer times the 1/12 to get that average of our function. And so just double checking our work here, when I type all that in, we should get an overall answer of 26 degrees. Okay, the second one, again, gives us that same question, but this time we're supposed to use a midpoint Riemann sum with 2 subintervals. So initially, again, our setup's the same. It's 1/12 times the integral from 0 to 12 of w of t dt. That's the average of the function temperature. And again, to approximate, this time we're going to use a midpoint Riemann sum, where it says here, but only 2 subintervals, which means that my first subinterval is going to go from 0 to 6, midpoint here. And so the length of that base would be 6, and the height, we use the middle value's height of 31. Our second rectangle would start at 6 and go to 12, again, a base of 6, and use the middle value's height for the height of our rectangle because of the midpoint Riemann sum of 24. And again, because it said average of our function, we're going to take that total, which is the integral, times 1/12 to get 27.5 degrees. All right. The last one on there says that they gave a function to model the temperature. So now they're proposing that this function would have given us the data you see in the table, or close to it, if we were to do like a linear regression or something for that. Anyway, a model for the temperature of the water in the pond. And it says use that function to find the average value in degrees Celsius over that time interval. So again, the same thing is we're looking for the average of the function, the average of the value of the degrees over that interval from 0 to 12. But this time when I do this, I actually know this function. Above in the table is called w of t, and this one that's labeled as number 4, it's p of t, but I can actually put in specifically what p of t is, 20 plus 10 times t e raised to the negative t over 3. And then this part, I'm going to go ahead and just math 9 that. So use my calculator to get this value for me. And when I type all that in, we should be getting 26.813.